Do 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 do. We're live. Woo.
Oh yeah, I see it. It announced it on my phone.
So it works.
Are you live?
We're live. These guys are like watching me, and we're being silly.
You'll be Simon Kang, the stupid astronomer, and I'm the guy on the left.
Get back to your chair. Anybody else want to join in? No. All right, we're just going to wait for our amazing audience to build up. Unless it's just Daniel watching me, of course.
Stop the D to you. Did you bring your tea?
No, it's just Daniel.
I bring my coffee.
Okie dokie. Can you guys hear us? Hopefully you can. We've got two people here on the YouTube stream. Can you guys hear us? Hello, hello, hello. Let's make sure everything's all working.
You're probably going to be in manual mode anyhow.
Yeah. Cool. But it works, though.
Yeah. It is.
Sorry.
Can you log into YouTube and see if you can hear anything on your machine?
I think, right? Well,
Yeah, just go to
you have to be
YouTube.
logged in now? Just go to
No, you just go to YouTube.
Well, I'm on it right now. I'm on YouTube.
Okay, so just search for Wooden Hills Camera and Telescope or whatever our thingy is called. I want to make sure that they can hear us. Not that they want to hear us. We're live.
There it is. Live now. Okay, let's hear it. Talk to me.
Oh yeah, perfect. I can hear myself already. Look at that. Massive delay. All right, so let's get this show on the road. So today we're doing simultaneous casting here. We're on YouTube, which is this guy here. So that's you. And this is Facebook Live. So Facebook, YouTube. And we're going to be talking solar. For those of you who know who I am, I do a lot of solar imaging and some solar astronomy. This is Daniel. He's trying to sell Takahashi baseball caps by the looks of things. You can get one probably from somewhere.
It's Takahashi, so it's $100.
Yeah, you have to buy the adapter with it to fit your head.
Behind you, though, that's probably about 100 pennies.
So let's get this started. All right. First things first, I'm going to go into the SolarScout from Daystar Instruments. If you guys, or Daystar Filters, sorry. So if you guys don't know who Daystar Filters is, they are probably one of the better people that make solar filters. The other two being Lunt and Coronado by Mead. There are a couple of other people out there, but these are more my favorites. So what they've done here is owing on the success of the Quark, what they did was they combined a Quark with a 60mm aperture telescope.
I didn't realize how heavy.
So you can kind of see inside of it. I mean, it's not a lot to look at because obviously the actual Quark unit is built into this. Now, basically, the way this thing works is you have to put power into these things. And what it does is it heats up a element on the inside that then, well, it heats up the Formica crystal that then essentially tunes the scope in. And you can actually change the temperature, which is this knob here. And each one of these shifts is essentially 1 angstrom in terms of the shift. And the idea here is you're trying to set this up to be the best view that you can possibly get. By default, most people actually have it set to the center, which is this mark here. And what this offers you is really good contrast views of the sun in terms of visual aspect wise. Now, where this particular unit excels at the most is actually for prominences. If you get some serious surface things going on, I don't know, like a flare or something crazy, you know, these things are a lot of fun. So you can play around with this knob, and the idea here is you can actually tell from the Doppler shift, is the object coming towards you or is it going away from you? I'm just going to turn on something off for a second. I'll be right back. Don't run away.
Multiplied by 0.71. So it actually
Sorry, I can hear myself on somebody else's machine. It's kind of annoying. Camera too high, just can't see the scope. Oops. So yeah, there's the scope right here. So again, there's the inside of it. Not a lot to look at. That's the business end of everything. Yeah, obviously you can't use this during nighttime. It's not designed for that purpose. This is really designed only specifically for solar. So going back into this, it's a 16 millimeter refractor. It's actually got the equivalent of 930 millimeter focal length. It's actually has a built-in telecentric Barlow that gets it to that focal length, because obviously 60 millimeters, how on earth are you getting it up that high without doing something like a telecentric Barlow or something along those lines? That's what these things have, and they're actually built into this unit. You cannot remove these. There are no user serviceable parts in these scopes. Do not dismantle them. You will void the warranty. Just as a precaution. Focusing is very, very simple. You just simply rotate the helical focuser on the front, and you basically just dial it in to the best view you can possibly get, and you're good to go. They do come with the solar bullet, I think is what they call this particular thing at the top here. And, you know, again, it's similar to all the other devices you may have seen out there from all the other solar telescopes. It works on the same principle. Sun goes in, casts the light onto this, and you essentially confine the sun with it. Comes with standard Vixen mounts with 1/4" 20 threaded bolts at the bottom if you want to attach something else to it, like say a regular tripod or something like that. You can do the quick release plate on there. These two screws do back out. You can remove this if you wanted to. Most people don't. It doesn't make much sense to have that part removed. It's just best to use those regardless. Again, standard Vixen dovetail. It's pretty simple. Now, more important is I always get asked this: can you do imaging with this particular system? Short answer: yes, you can. Of course, you can. These things actually, or if you're familiar with Quarks in general, they give probably some of the best images that you've probably seen out there. Again, if you follow my Instagram page, Simon2940, you can see a lot of examples taken with different solar telescopes, and you'll notice that the one that I use the most is actually the Quark, which I'm going to show you next. Again, I've used this smaller scope. It's great if you're trying to do full disk size. It's not all that if you're trying to do like close-ups. If there's something really going on, like a good active region, and you want to see, you know, all the bits and pieces jumping out at you, this probably may not be the right scope. They have the bigger version of this. They go up to 90. They even have a 127. That thing is just unreal. I mean, you are literally like swimming around on the surface of the sun. That's how crazy it is. And when you get to that stage, capturing the data with something like this, it's just mind-blowing. I mean, I've had every other solar telescope you could ever imagine, and again, I'm always finding myself coming back to Daystar, and it's like the benchmark for me. You know, that's where I start. So that's the SolarScout, and next up is the actual Quark itself. This one is actually called the Quark Combo. Again, it works on the same principle. As you can see, this piece here is essentially the same as that part there. You can see it's pretty much identical for all intents and purposes. This particular one is more designed for SCTs. You do have to figure out your own way to choke down the aperture. Ideally, they would rather you operate anywhere between F27 to F30 roughly. I've experimented again countless times. It seems to be the best number is around about the 27-30 mark. You can be lower. You can be as low as, I think it's like F15, but that's like pushing it a little bit there. Again, there's two versions of this, and you've got to be careful. If you already own a refractor, this is not the right version. You need to use the regular Quark. This particular unit is the Quark Combo. I've just got it out for just display purposes, just so you guys can see it. It's very, very straightforward. You simply take this cap off and just bloop, straight into the scope, and it basically has the blocking filter on the front of it right there. If you get the regular version, the actual blocking filter on that one is already choked down, so you don't have to worry about anything from a refractor standpoint. 9 times out of 10, the bigger the scope, the better it gets. The only drawback to having a big scope, say anything above 120 millimeter front aperture refractor, you have to have some form of ERF at the front, not the back. So by default, what we tend to do here is scopes below that. I mean, with a 127, you could just about get away with a UV IR cut filter, but for God's sake, do not buy cheap ones. They don't work very well. They don't last very long. So, you know, at the end of the day, for your own protection, you know, if you're going to spend $1,200, at least spend $100, maybe more, on the UV IR cut filter. If you go for apertures like, say, 150 millimeters, the ERF is the most important thing. You'll hear phrases like, you know, DERF or just regular ERF. They're pretty much all the same thing. The dielectric version of the ERF has more like a mirror look to it, whereas a standard ERF tends to be a colored glass filter with UV IR cut filtration built into it. 9 times out of 10, they're red or yellow. More commonly, you'll see them being yellow than anything else. Personally, they make no difference. It's just how much money do you want to throw at the entire thing. Again, these are a requirement. They are a necessity. You cannot just buy this and off you go. You have to get some form of energy rejection filter. Do we have any questions yet? Don't be afraid to ask. I don't bite. Not yet anyway. No? Oh, it's a shame. Well, okay, so let's go into some of the more interesting side of things. What do you get with this scope? So you can buy the scope by itself. I'm not going to give you prices. I'm sure you guys can look that thing up. You can buy the scope by itself, or I actually like the kit version of this. I've actually sold quite a few of these myself personally, and again, most people tend to go for the kit version. Why? Well, it actually comes with a white cardboard box. No, it's not. It's actually what's inside the white cardboard box that's more important. They actually give you their own power pack, which looks like this. There's their power pack. Daystar. And it's basically a very similar principle to their phone chargers, or sorry, similar to phone chargers that you buy. However, the one unique difference here is if you look here, I will show you guys here on Facebook in just a second. If you look right here, you can actually see where it actually tells you what the amperage is. And in order to power any of the Quarks, regardless if it's the SolarScout or anything, you have to have a minimum of 2 amps. So for you guys over here, there it is right there, 2 amps. You've got to have that as the minimum. And then you can charge your phone off of these things as well. Very, very simple. Just press the button and they turn on. It comes with the cable. You can charge it with any USB devices. Chances are you probably have a phone that has the USB connection. It's a 2.0. I'm trying to remember the name of the type again. It's like version 2 or something. It's basically micro USB, for a lack of better description. Again, most people who have Android phones will already have these cables. So, you know, you can charge your phone with it. You can power the Quark with it. And that's really about it. It's just a pretty much standard battery pack. Little LED warning light, so it tells you when they're actually charging, and it will cut off. When it actually does reach full, it will shut down. Lithium-ion technology, or lithium-ion based technology, has 10 amp hours of total runtime. In all honesty, if you're crazy enough to sit in the sun for 10 hours, this will last you the entire day from morning to night. I mean, it doesn't actually pull 1 amp, in all honesty. It's actually closer to around about 500 milliamps, but it doesn't require a lot of power. So it's pretty straightforward. Other accessories that it comes with, the actual power supply is actually in here. I'm not going to pull it out because of all the plastic baggies, but you kind of see inside there. I know it's not fascinating. It's just a power supply. Again, it's just got a USB connection on the other side. I'm just grabbing this. This is actually the box that comes in. Instruction booklet, because let's face it, nobody reads it, but I recommend you do read this. It's vital. Remember these? Oh my gosh. This was like a madhouse back in 2017 when everybody wanted these things, and they actually give you one. Actually get an eyepiece. In this particular case, you get a Plossl. This is a 25mm Plossl. There's a reason why they give you the 25 Plossls. Usually when you're doing solar of any description, the idea here is you don't want to lose contrast, because it's bad enough as it is without any contrast. So what you kind of want to try and do here is have as few elements in the way as possible. So Plossls by design have the least amount of elements, so you don't lose the contrast behind them. That's why Coronado, for example, from Meade has their CMAX system. They're all Plossl driven. They just have UV coatings on them and UV IR cut coatings on them. Same principle with these particular guys as well. These at 25mm on that particular scope will give you a full disc view. If you do imaging, on the other hand, you will not get a full disc. Just be aware of that. So it's a different thing or a different setup altogether, depending on the type of camera. For a scope as small as this one, because this is a 60, you've got two choices essentially. You can either use the 174, which will give you roughly, I'd say a little over 2/3 of the sun. Ideally, if you want to, because of the size of this, you want a slightly smaller pixel here. The 178, doesn't matter who makes it, ZWO, Meade, whoever, just as long as it's a 178 of some description, will get a full disc quite easily with this particular setup. Going back into what's in the box. Another box, a box in a box. To make your life a lot easier, they actually give you a diagonal. These are nothing special. They're just dielectric diagonals. Nothing specifically fancy about them. One major advantage about having a dielectric diagonal like this is the heat is not reflected at you. They actually end up absorbing the heat a lot of the times. I've got countless dielectric diagonals that I've used in the past, and they're actually a lifesaver in terms of your own eyesight, because let's face it, I don't want all that radiation bombarding my eyeballs. I like to keep them. It's bad enough I wear glasses. So again, it comes with the diagonal, put the eyepiece in and off you go. So it's very, very straightforward. That's why I like the kit, because everything you need to start doing your solar observations is already in the box. And again, they have all different sizes of this particular scope. Pricing, you can find that on our website if you want to check that out. It's telescopes.net. Just type in Daystar and every single Daystar product will show up. Now, that's not the only side of things they do. Going back to the Quark filter for a moment, both this filter and the SolarScout are chrominance, or chromosphere, excuse me. Well, technically it could be chrominance too. It's chromosphere. Basically, that's the part of the sun that we are looking at. And for those of you who are familiar with the terminology, it's basically hydrogen alpha. Now, I will say this. This does not mean that you can use your ZWO H-alpha filter or your Astrodon or whoever filters that you have that happens to be H-alpha. It doesn't matter if it's a 3 nanometer, 5 or 12 or whatever nanometer. They are not designed to be used for doing solar. They are for nighttime imaging. So you have to use something like this, which more importantly has a blocking filter. So I'm going to, hopefully Jen's not watching. She's going to kill me if she ever saw me do this. That's the actual blocking filter itself. Okay, this one's a little bit dirty, but it's not actually going to affect the performance. It's not uncommon for them to be like that. You guys over here, there it is there. Oh, look, I can see myself. I'm seeing myself. It looks like an infinity mirror. Where is it? Where am I? Anyway, we'll ignore that. So yeah, this particular one is the H-alpha version. You can kind of tell because it's got that reddish bluish tint. It's basically what we do as the redshift blue shift. That's actually how these things work. They have different variants of the chromosphere. They even do a prominence version. Now the big difference here is the performance value on the Quark chromosphere is anywhere between 0.7 and below. 9 times out of 10, you very rarely get a dud these days now. 9 times out of 10, when you do get one of these filters, most of the time it's already tuned to be 0.5. That's basically the number that you kind of want to be at. It's nicer if you can get like a 0.4 or a 0.3, but they're kind of rare now. Again, each one of these clicks is the equivalent of 0.1 angstrom changes, essentially. What I found, depending on where you are and your equipment setup, the amount of heat that you're getting, because obviously I'm here in California, so when I'm sitting out there baking in the sun, it's really, really hot, and I only have this 2 clicks over from an imaging standpoint. The reason being here is it's always offered me the most amount of contrast from an imaging perspective. When I'm doing visual, however, I like to have it roughly the middle way mark. It seems to work better for one system versus the other. I'm not sure why. One of the things that I will mention when you're doing imaging and you're playing around with these knobs, and I get this constantly, and I see people talk about it on all the different forums, is when they turn it and they say, oh, but the element heats up and I get these patchy things. Well, you're not supposed to be imaging during the heating phase. Of course, it's going to be patchy. It's like any type of heating element. You've got heat zones. It's like an oven at the end of the day. Different parts of the oven get hot at different points. However, it does become uniform, which is why there is this LED here. What happens here is when the actual element heats up and it's at a uniform temperature, does it go green? Once it goes green, you're ready to go, and it's relatively uniform. A lot of people don't realize this, but you are supposed to shoot flats. You're probably going to go, how on earth am I supposed to shoot flats with one of these guys? It's not easy. Well, actually, it's a lot easier than you realize when you're doing imaging. Is you basically get to the middle of the sun where you don't see the edge of space anywhere, so you've just got essentially a white screen, and you defocus it. You can do it either or way, focus in or focus out. My personal preference is to focus in because the dust motes tend to show up better. The gradation of the darker areas is a lot more smoother, and there's various techniques on how to apply flat frames, and it's well documented in all different places. Again, it's very, very simple, very, very straightforward to a certain extent. I think most people tend to trip up on that, is that they're expecting the image to come out of the box looking like, perfect crystal clear images. It's not the case. You do have to do some processing. There is a bit of work around that. If you do a YouTube search for asteroid hunters, I actually run through a quick tutorial on doing processing for solar, 2 different methods. Whichever method is you prefer, we can do it. You can do it that way. All the software is free, so why not have a go at it? Again, the prices are on our website. It's telescopes.net, so I'm not going to give it away here. We'll scare you guys. There are actually other versions of the Quark. It's not just H alpha. They also have calcium on the 2 different bands. I think it's calcium H line that they have. They have sodium D line, and they also have a magnesium, if I remember correctly. So I'm going to explain this real quick. All these different types of filters look at different layers of the sun. I wouldn't really call it a surface because the sun doesn't really have a surface per se, but when I'm looking at the chromosphere, we are looking at the hydrogen alpha wavelengths specifically. When we go into, say, calcium H, we're looking at the calcium H line. What that tends to look more like is if there's some really good sunspot actions going on, we can kind of see all the bits and pieces that kind of make up the actual sunspot, and it kind of just spreads outwards. I'm not using any of the terminology because I want to keep this real simple for you guys. It's actually called plag and things like that, but we don't want to confuse you guys. But the way I can describe the way it looks is if you think of where the actual sunspot is on the edges of everything, it kind of looks like this, somebody like just threw sand at it and smeared a hole into it where the sunspot would be. That's the best way to describe it. And it kind of arcs out. It looks like lightning almost. And then magnesium, on the other hand, is very different on the way it looks. It's similar, but not quite the same. What happens here is it looks more like cracked glass than anything else. The only problem here is though, between those two, the calcium line, the sodium and the magnesium, it doesn't look as good as it would do compared to, say, H-alpha. In some cases, people with older eyes, especially who have had cataract surgery, tend to say, they can see more in the calcium line. So, if you're struggling with that level, the calcium side of the filters is really ideal for you. Me personally, I can't see anything. I'm short-sighted, or nearsighted, whichever way you look at it. I don't see that kind of stuff, which is kind of why I prefer to do imaging. Again, if you're using it with an existing refractor that you already own, you have to have some type of ERF or energy rejection filter. Smaller scopes, you can get away with a UV IR cut filter. Again, do not cheap out. Just because it says $20 does not mean it's a good filter. There's good examples, bad examples. We sell filters here all day. We sell filters for cameras. When you buy a $20 filter and then you compare it to, say, a $120 filter, there's a huge difference when I hold them up. And some people will turn around and say, it's not worth it, or I'm wasting time, I'm wasting effort. Remember, it's safety at the end of the day. If you plan to look through this with an eyepiece and there is not adequate protection, you're going to basically burn a hole in the back of your head, for a lack of a better description, and you're going to look like One-Eyed Willie from the Goonies. So, any questions yet? Let's have a look.
Yes, please.
We got a couple of people over here, and we got you guys over here. There's 8 of you. Where is everyone coming from, or where is everybody watching from? I've got 1369 Buddy. Hello. Richard Roman. Hello. Mr. Charlie Walsh on this side, maybe. Hello. So yeah, any questions? It's always the problem with doing a live stream, because I'm sure I'm going to get bombarded with questions afterwards, as I usually do. No questions. Okay, let's look at something else then. So, how useful is this for the eclipse? Let's look at it that way. Interestingly enough, when you're doing the eclipse, it's a weird situation where it's more of an experience type thing. It's really weird. I wouldn't actually use a hydrogen alpha telescope, strangely enough. It seems like it's wasted and lost. You kind of want to experience the whole thing in white light. What I've done before in the past, when I've done the eclipse, because what I did was I was the guy that took the shot of the International Space Station transiting the sun during the actual eclipse. Is like 49% coverage. You'll find it on NASA's APOD astronomy picture of the day. What was the date? August 20 something, I don't know, 2017. That's when it's listed, so you can go check that out real quick. That was actually a composite image of both hydrogen alpha and white light. The hydrogen alpha side of things was, I wanted to show some kind of texture, because most of the times when I see these transit pictures of the sun, doesn't matter if it's like if it's an eclipse or the International Space Station or even a plane flying past, it's just a big white circle. That's all it really is. So I wanted to have a little bit more dynamic in it. So I actually had to dismantle my setup and get the hydrogen alpha scope up on there and start shooting that. And I collected all the data, and you can see what the picture looks like. And it made a way more interesting shot than what other people did with just a circle. Anybody can do that, I guess, for lack of a better description. So yeah, when you're doing the eclipse, white light tends to be way more of an experience. Plus, when the actual eclipse, when totality actually occurs itself, you kind of want to experience the whole thing. And what people tend to do is take the filters off, because you can actually see the corona Unfortunately, there are no solar telescopes that are affordable that you can actually use to observe the sun with. I'm talking about a chronograph, in other words. There's not really one widely available that we could just get our hands on and go, woo! So it's very, very different, but the experience is just completely different. I wish that somebody would come up with a chronograph that you can afford and buy. You know, I'm not in the mood to spend $200,000 on a chronograph. But they would actually work here on Earth, not brilliantly, but they will work. Obviously, if you're in space, they work even better. But you know, with imaging techniques from today, they actually work incredibly well. So, buddy, you're not into photos, so you're more of a visual guy. That's basically what this lends itself better to. If you're planning to doing imaging, I strongly recommend getting a refractor of your choice and then using the Quark. In this particular case, this one's made for the SET. That's why it's called a Quark combo. Don't know why. This one is more geared towards visual astronomy. These are achromats, and these are only doublets. In all honesty, you don't need anything fancy. In fact, it's probably best that you don't spend a ton of money on the scope itself, just purely because you can spend a ton of money on, say, like a 120 apochromatic scope and so forth and so on, but is it going to offer you any better views compared to, say, an inexpensive achromat? Well, not really. I've shot countless times with all sorts of scopes. I've even used the Celestron C6R, if you guys have been around to check that out. That's always a fun scope. It's massive and it's heavy. I've used that a handful of times. Visually, that thing is just funny as hell, because there was a sunspot that had come round. I did everything. I did white light, I did H alpha, I did calcium, and I did a mixture of both visual and imaging. Obviously, imaging, I can show you the final image and you guys get to check it out. But visually, when you're looking at a sunspot in H alpha, it's quite an experience. It doesn't look the same as you would do in white light. White light, unless you've got high magnification and you've got a whole bunch of filters, like Barda's solar continuum filter, it's very, very hard to see anything with an aperture that big. What, again, it should look like is, if you can imagine a safety glass and somebody just came along and smacked it one, but it didn't go anywhere, it just stayed in one piece and you get all the complete breakages. That's exactly what the